Asante Emmanuel, please, can you hear us? Okay, Stephen AJ. Stephen AJ. Okay, Stephen Edu.
Oh, okay. So the
Yeah, Stephen Edu, go ahead. Stephen AJ will
okay.
come back to you later. So
So
Stephen Edu, go ahead.
the system is a group of interrelated components working together to achieve or working together towards a common goal. So, for instance,
Okay.
we have. So can I continue?
Yeah, go ahead.
Okay. So, for instance, having a computer at home, the computer is made up of different components, or a TV is made up of different parts, which comes together for us to be able to view or see whatever is happening on the computer or the television.
Okay, so using the computer analogy, can you show us tell us some of the components that they come together to work to project that common goal?
So we have the hardware component, which talks about the physical part of the computer, and we have the software component. Without the hardware component, which is the computer
So
or the
example
laptop
of the
itself,
hardware, the
you
physical
can't
part.
say we have the motherboard and the system unit.
Uh-huh.
We have the
Okay,
monitor as well,
sure.
and with
Uh-huh.
the
So see,
software
so when you are explaining something, when a question is being asked, either in a written form or in an oral form, these are some of the examples you are supposed to give to justify the point you are explaining. Are you getting it? But when you mention physical component, the hardware, and you don't mention example of the hardware, it makes it a bit hanging. I get it. So thank you for mentioning those examples. Thank you very much. Stephen
okay,
AJ,
sir.
and please note, I normally pin down those who have been contributing in my class. So when I call you and you don't respond, then it means that you don't participate. And those who participate in my class, I have a way of rewarding their contributions. So take note of that. So those that I call you and you are quiet, you don't want to talk, that's fine. Okay. So far, when we started, there are some people that they have been, anytime they are dominating, contributing, and I appreciate it so much. I've taken notice of those people. Okay. So Stephen AJ, let's hear you if you are ready. Okay, Ebenezer, Ebu. Ebenezer, Ebu, please go ahead. Your hand is up. Ebi, can you hear me? Okay, Osekufo.
Okay, sir. The system approach also helps us to analyze and then understand the operations that exist in the system. So, like the examples that our brother gave, using the computer as a system. So the parts, which is the system unit, and then the monitor also helps us to understand whatever the um, the system is. Thank you.
Okay, thanks for the contribution, Stephen, Edu, and Osekufo. Yeah, so that means that it's only the two of you who read the material I sent to you. I see. So, as you have already indicated,
Okay.
the basic concept is that when we talk of a system approach, as you have said, they are group of components, and these group of components, they are interrelated, or they are common. They have commonalities, and these group or components of interrelated parts, they work in unison to achieve a certain purpose or a common goal. And once they do that, they accept inputs, they go through the process and produce what? Output in an organized, take note, in an organized transformation process. So the examples that have been cited, like the computer example, we see that we have the monitor, the system unit. Some of them you may even see the other parts, software parts within the system. And also some you will even see speakers and other things that work together to produce the tasks of a computer. We can also say that a system is an aggregation of various units interlined by a complex set of relations which work together to make the system function as a whole. Now, this system unit can be used as a framework to help us appreciate and understand the operations and interactions which exist between a system around us. So, for example, if you take agriculture as a system, okay, let me talk about it. So, this is a general system approach, a simple system approach framework. So, every system has accept input, process it, then give you output. Then there's a feedback from the output and to that of what the input. So this is a simple framework of a general system. Now, you can use agric as a system, for example. Agriculture as a system. Within this agriculture system, there could be a number of components. We have the farmers component over there. We have the NGOs into agric component over there. We have the government agencies component over there, who are the Ministry of Agric, those departments and those who are into agric, like Cocoa Board and those kind of are also another component. Then even financial institutions that give loans, like a agric development bank, are also another component. Then we even have international partners, World Food Organization. Those organizations who are international partners who support, they are also another component. And all of them work together to get a better agriculture system for the country. They don't work against each other. They work in isolation with the ultimate aim to get the best agriculture system for the particular country. Are you with me?
Yes, sir.
Yes, sir,
Okay.
please.
So now let's look at some of the features
Yes, sir.
of a system approach. We are saying that one of the features is that all systems are composed of interrelated parts or subsystems. Yes, all of them. There's no system that do not have parts. If they do not have parts, then there's not a system. So every system are composed of what interrelated parts or components, or they have subsystems. The system can only be explained as a whole. Take note. Another feature is that we don't explain these systems, this part, in isolation. We connect each other to we explain the system as a whole. That's why when we are talking about agriculture system, we are explaining agriculture of system of Ghana as a whole. But in the explanation, you may be able to identify the various parts that are within the whole. So you don't take government and talk about government without looking at other parts of the agricultural system and how they are collectively working to achieve the whole of an improved agricultural system in Ghana. Then we also have systems are hierarchical in that the part of the subsystems are made up of other smaller parts. Yes, when we say hierarchical in the sense that they are the major parts which may also have sub ones. So for example, like I mentioned, in agricultural system, we have a major part which a component like the Ministry of Agric. And within the Ministry of Agric, there are agencies under them who are like Cocoa Board and Agawa and other seedling, tree planting and all forestry and all those. They are all part within the agriculture system. So in terms of hierarchical, Ministry of Education, Ministry of Food and Agric will come first, followed by the various units, agencies like Cocoa Board, and those parts of the that come. That's why I say hierarchical. Are you getting it? So it's made up of the main parts and other sub part that falls under the system. Now, part of the system cannot be altered without affecting the other part. Another characteristics of a general system is that the moment you alter an aspect, a system, it affects the rest because they all work in unison. So when one fails, it affects the other. So you cannot alter a component of the system without affecting the other part. Obviously, it will affect. It's just like you are talking about computer. When the monitor is not working, how would the system unit and those things get you the feedback? It's either you get another monitor or you are able to connect it to your TV that you can show. Is that also?
Yes, please.
Yes.
Yes, sir.
Yes, sir.
So the issue is that
Yes, sir.
the moment one part is altered, automatically it affects the other part. If government, cocoa board, farmers of cocoa are produced, and government is supposed to pay them, and they are not paying, and they are not getting the money, how can they produce again? So obviously to affect the output of farmers. So that's what we are talking about. Now, subsystems should work towards the goal of their higher systems and not pursue their own independent objectives. So like we are saying, that's why I said they work as a whole. So the higher systems, like example I gave, the Ministry of Agric is a higher system, having agencies like Cocoa Board, Cashew Board, and all those kind of agric farmers, the grains and all those things, they all work collectively to achieve the purpose of the agric as a Ministry of Agric. So one of them cannot work in isolation with having its own objective different from what the general objective that they are supposed to achieve. That's why in every of these agencies, you will see that in the board, either the Deputy Minister of Agric or the Agric or the ministry has a representative in each of these agencies they are board, so that they check to make sure that whatever you are doing is in consonance with the policy of the ministry. And the ministry is not also there doing its own thing. It's also there to fulfill the policy direction of the government in power. And that is what we want you to. So if you go there, you are doing anything, then the president can just sack you and bring in somebody who can work in line of his vision. Then we're also saying that a system Organizational system contain both hard and soft properties. So like you said, it's not all that. At times, some of the systems, so they are not all that is the hard that you can see. For example, the computer examples we mentioned, there are some softwares within the system unit and which all are soft properties that collectively work. At times, you may switch on the system unit, the monitor will come, but the information that is supposed to process is not processing. That should tell you that there's a soft aspect of the system that if it also does not work, it will not also work. I remember there was a time I switched on my laptop. You see that the light will show that it is coming, but the writings were not coming. So I said, and they say they removed the memory and they cleaned it and inserted it again before it came. So that should tell you that in every organizational system, there's a hard as properties that are tangible and visible, but there are also soft aspects that may not be seen, but they also equally work in the achievement of the system. Now, types of systems. Types of systems. We have closed systems. One of the types of systems, you have closed systems and open system. The difference between the two is that a closed system is one that is isolated from its environment. Isolated from its environment means that it does not allow an inflow from the external environment to affect the system. That's why we are saying that it shows any kind of exchange with the environment. It is self-contained so that the external environment does not influence the behavior of the system, nor does it influence its immediate environment. By so we are saying that a closed system is a rigid system in nature, and it has a well-defined boundaries, which is not adaptive in nature. So the difference between the closed and the open is that the open system interacts continuously with the external environment. It exchanges with the environment, but the closed do not. It is rigid. So take note of that. I remember last year there was a question like the difference between closed and open system. But it doesn't mean that it will come this year. I'm just saying it for saying sake. So the lotto casters don't say because last year it came, it will come again. No. Okay. So a closed system receives no inputs from its environment, and because at times it does not, at times entropy or decay set in most of the times. Now, a typical example of a closed system I want to give you some example. You know, thermoflax, which I know a lot of you have been using it. Thermoflax.
Yes, sir.
It's a typical example of a closed system. That's why the flax is designed in such a way that it does not have any exposure with the outside the environment. So the flax prevents energy transfer of leaving the flax inside. And that is a typical example of a closed system. Then laboratory experiments is another example, especially those biology, chemistry, and those kind of lab experiments, which the chemicals are such that if they're exposed to the environment, it can cause a disastrous behavior like acid and all those kind of things. So most of the laboratory experiments are seen as a closed system because of the chemical reactions that may be created if it is exposed to the environment or if it has some contact with the environment. You can also talk, another example is the, yeah, there's a hand up. Please go ahead.
Sir, please, I wanted to ask, the systems, I thought they were related to something geographic. So when you gave the example of the Ministry of Food and Agriculture, I was thinking maybe there will be an example within that space that will portray the closed system. Thank you.
Okay. Any other question? So that I address all of them as one.
Sir,
Please go ahead.
please, what about those who use dynamite to blast rocks, heavy rocks? Is it a type of a closed system or what? I want to find out if using a dynamite to blast heavy rocks can fall under a closed system, as an example.
Now, so in that case, what system are you talking about?
I want to know from you if it could fall under a closed system or open.
No, what I'm so if you say that a dynamite, what is a dynamite used for?
For I know of those ones used for blasting rocks. Hello.
So when you use it to blast rocks, does it?
You know, but
The
I
rocks,
can't
is it
remember we
within the
had
environment or is within the crust?
within the crust and sometimes outskirts of a community. But sometimes I can't remember last year or two we had a situation whereby they use these dynamites to blast a rock near castle or somewhere. It caused serious dangers and then casualties. So I'm just asking.
Yeah, that see, we are talking about a system that we are saying it has no relationship with its external environment. It doesn't interact. Are you getting it? So, and you see, most of these quarry site that you go, it is some of these things they use to blast. Are you getting it? And these quarry sites, these are open areas. Though it may be outskirts the community, it doesn't make it a close area. Are you getting it?
Okay, so
Any other before
Sir, please, you can continue.
okay, so there was a question that was said when I said thermoflax is one of it was a basic example. I know that most of you are familiar with that, why I use that. I getting it when I use the thermoflax because I know most of our ladies and even these days guys, I even use some. So I know that that's the example that I. But the second example is in the area of geography, spacecraft. Spacecraft is a area of geography, astronomy. You see,
Okay, sir, I
anything
understand.
that prevents energy transfer within it is a typical example of closed system. So at the end of the day, when you see that the air spacecraft, when it is within the air, it is basically, you realize that any serious interaction that it's the least that it will hit with the external environment can create a danger. That's why some of the aircraft and space aircraft, some of them has even been designed in such a way that even in a foggy weather or even in the night, deep night, they're able to penetrate and travel. That's why those that are dependent. So I remember the recent case that happened. People were saying, oh, the area was foggy, the weather was like that. Why was he flying and all those things and that? And when you check the experts, they said that that aircraft was designed in such a way that no matter the nature, that's why I say soldier helicopter. You see, it doesn't have to, that should not be the cause of it. That means that something went wrong within that system aircraft, because the aircraft as a system has a lot of parts that must work, be it soft parts and the hard parts. So the fan, the tail, the gasoline side, and all those things could be the physical, the hard. And the compass and the systems within the inbuilt aspect will also be the the soft parts. See. As for the laboratory experiments, it's cut across all areas. Cut across all areas. Then talking about the open system, it's just the opposite side of that of the closed system. And example of an open system is the human body yourself. The human body is a typical example of an open system.
I mean, the solar system.
Pardon?
Even the solar system is also an open, a type of existence
So
under open.
yeah, the solar system. Yeah, because the solar system, anything that interacts. See, that's why I say human system, human body is a system because one, we take the air that we breathe, the energy, heat energy, and all those things that we need from the sun, which is external. And after our processes, we also give out some carbon dioxide back to the environment. Are you getting it? So anytime you hear the concept open and close, you should know that the open interact with the atmosphere. The same thing, the ecosystem. My sister wants more in geography. Ecosystem. For example, a forest ecosystem exchanges matter. For example, you see the forest, the plant, and all those things. Do you know that they give us the oxygen we inhale?
Yes.
Then we also give them carbon dioxide that they also need to prepare their photosynthesis. And the plant also need the sun, the energy, the sunlight. So a forest ecosystem is a typical, or ecosystem in general, is a typical example of open system. River system is another example of open system. So you could see that a lot of rivers, they flow into the one bigger ones, and where they are sea, their ultimate is to end up in the sea. So but when you look at like the spacecraft, the the closed ones, they do not exchange anything with the outside or the environment. And that's why I use the typical example, a simple example like the thermoflask. The energy within is not allowed to expose it to go out. Unless you use maybe certain cold water that could spoil the flags and all those the thermoflags and all those kind of things. So these are some examples. There are lots that probably you can come across them. So take note that whilst a closed is rigid, do not interact or is not influenced by the environment, the external environment. Open system is influenced by the external environment. That's why I say it's received inputs and influences from the environment and in turn passes back output, feedback, and influences to the environment. Then we have simple system. A simple system comprises, so here's a system output from non-input, and it does not require high-level system analysis. Now, in brief, what we are trying to talk about when it comes to a simple system comprises a small number of components that interact in a straightforward or linear manner, like the framework I showed you, which is input, process, output, and a feedback. That is a typical example of a simple system that I showed you. So these, they are smaller number of components, so they are not many, they are smaller. Let me see if there normally there's a diagram. For this one is very complex. This is a complex system. So the first diagram I showed you is a typical example of a simple, this one. It's an example of a simple system. The components are not many. That's why we say that it comprises a small number of components that interact in a straightforward linear manner. And that's why we said that in the PowerPoint, we said that these parts, the behavior of the system is known, is predictable. Yeah, so is it possible to define? It's possible to define system output from known what input, and it does not require high-level system analysis and review, because these are small component parts and they operate in a very straightforward linear manner. And because the components are not many, it doesn't make it so complex. And at the end of the day, their behavior, their processes, their function is virtually predictable, because what you input in, that's what people say garbage in and what garbage out. So what you feed with it, the process and the output will give to you. Unlike the complex ones that they may go through some nuanced activities, so that by the time it comes out, it may not be the thing that you thought the simple may be able to provide for you. Now we have a dynamic, so for an example of some of these simple systems, you can let me use the things that we are familiar. Well, so pardon me, my lady. I just want to, most of the examples, I just want to use things that are so familiar to us so that we can relate more than going too technical in the area of geography. I get it. So, my lady, if you don't hear more of the technical concept in geography, pardon me, I just want us to just get the basic things to familiarize ourselves with that. So, for example, the toaster machine that we use to toast our bread is a typical example of a simple system. And I like toasting bread a lot. So that's it. So pardon me if I use that example. I like it. The clock we have been using, all our clock, the clock we have been using in our homes and our wrist clock, they're all simple systems.
So another example is the switch.
Yes. You see, so the unique thing about a simple system is that one, the components are not many, and two, their actions, behaviors, their processes, activities are predictable. Because it's simple, like I said. So if you input in this thing, the process, and you get your output. So it's they have actions, behaviors, and those things is quite predictable. And that's why we are saying that because of that, because the parts are not too many, it doesn't require any high level rigorous analysis and review when it comes to a simple system. Now, but when it comes to what we call complex system, now, okay, let me talk about the complex was before I come to the dynamic one. Oh, okay, that means I jumped one. Okay. But let me talk about the complex. Maybe I have to chip in. Complex system is the opposite of a simple system. Before I think so it's not on this particular slide. So after maybe I'll have to chip in and forward it to you again. It's just opposite of the simple system. Once we are saying that the simple system is very small number of components, the complex one, it is made up of what? A multitude of parts, many parts. And when it comes to its relationship, it involves a number of structures, a number of elements that are arranged in structures. And their actions and behaviors are not easily predictable, unlike the simple system. Hence, complex system requires high-level system analysis and review, and it is not, like I said, easily predictable, unlike the simple system. Are you with me?
Yes,
So
sir.
if you look
Sir.
at the example that I just showed you right now, which is a hydrological system, it is a typical example of a complex system. You see the things, because when precipitation takes place, there could be a number of areas these water will go through. So we have the interception storage where stem flow and drip. We have the surface storage where infiltration could also go to the soil moisture storage. Then we have the seepage. Then the groundwater recharge goes down to the groundwater. Through that process, we have what we call the overland flow. That's the surface flow. Some will overflow on the overland. Then the soil moisture, so we have through flow, interflow, then the groundwater flow. They'll go to the channel storage and a whole lot of complex activity, which is quite different from the simple system, which will just move from input, process, output, and feedback. You see that? And these go through some nuanced activities, which the diagram itself gives you a picture of what happens when it comes to complex system. So looking at this, I would like to pick one or two examples from you as well. Anyone? Yeah, Amwa, go ahead.
Soil formation.
Soil formation. Can you explain how you believe that soil formation is a complex system. So show us with some of.
Right. Okay, so looking at the processes that come together in soil formation, like the weathering of the rock, for instance. So the weathering of the rock goes through certain processes, whereby we have aspects which is caused by man, and then natural features. And then looking at human interaction with the environment. So looking at all these activities, we can say that the formation of soil is an example of the complex system.
Okay. Yes. And another, you see, some of the examples we even cited in the open and some of the examples we cited in the open system, is even can also be examples of complex. For example, ecosystem is another example of a complex system. The climate systems that we are talking about, climate is another example of a complex system where we have a global atmospheric circulations, we have oceanic circulation patterns which influence the weather and climate of a place. So ecosystem, as we started, it's an example of a complex. Climate systems, example of complex. In fact, even traffic systems can be a complex system where we have interconnected routes, vehicles, infrastructure, managing flow and congestions here and there, and all these nuances when it comes to in that area. Okay. Any question? Okay, let me add a dynamic so that that's the dynamic system. Then we can make some progress. So dynamic system, say the word is dynamic. Dynamic means that it's not static. Dynamic means that they variate. They can vary at any point in time. That's why we are saying that in dynamic system, one of their critical features is that they fluctuate rapidly. They are constantly changing. This is a system which comprise a large number of interrelated or interconnected parts or components that interact in complex and non-linear manner. So the typical features is that one, they fluctuate rapidly. They are constantly changing, either through their exposure with the environment and other forms of exposures or interactions or influences from the environment. And we are saying that such systems have the capacity of remembering what it had been subjected to previously or has some memory built in them. So these are unique features from the dynamic system from other systems. So we are saying that in dynamic system, another thing you can also talk of is the fact that, yes, that's what is here. There are dynamic equations or differential equations of appropriate type, and their boundaries can be difficult to identify when systems are very dynamic because they are changing at any time. And a typical example of dynamic is human body system and weather systems. Because, for example, right from the day you were born, I'm not sure your body has been just as it is up to now. Is there anyone like that here? Is there anyone like that here? From the time you were born, you have been just as you are up to now.
No,
That was
sir.
No, sir.
You went to what you call adolescent stage, things changes. There were a lot of changes about you. Then you got to the youthful stage, a lot of changes. And some of you, as you are going to the 40s, a lot of changes are coming in again. That's a typical example of dynamic. And so it becomes very difficult because of their dynamic nature, how they change rapidly, constantly change. It becomes difficult to identify their exact boundaries because of the changes, the metamorphosis they go through as they progresses. The same thing, weather systems. Today is cold, today is hot, today other influences are affecting the weather. So it becomes difficult to determine. Even these days, time that we're expecting rain, we're not getting it. And the time that we're not expecting it, it was coming. Weather changes, fluctuations, and all those things are making it difficult to determine some of these things. So these are some of the examples of dynamic system. Stephen, your hand is up. Let me hear you. Stephen Edwin. Stephen, your hand is up. Okay, Prince.
Yeah. Please, can you say that tides is also one example of the dynamic? That is the rise and fall of the sea level.
He said you can say that what?
Yeah, I said tides, the rise and fall of the sea.
No, you see, if we are talking about, we are talking about a system. We are not talking about parts of a system. That's why I mentioned example like if you are looking at, let's say, oceanic system, then these things can be form part of what? The oceanic system. Are you getting it?
Yes, sir.
So which this tidal wave, which could be low tide, high tide, could form part of a system called oceanic system. Ocean as a system. Then these parts will all be featured in there. Don't forget that we are saying that this system, they don't work in isolation. They work to achieve the common goal of a broader system. Because within that, that's why you can be talking of a component of ocean current, that monsoon wind interaction, where you can talk of Coriolis force, which cause about the deflection of the monsoon from its direction and all those kind of activity, which all these things affect the tidal waves as well. So we could see that their interrelatedness and their activities collectively gives you the picture of the ocean activities that as a system.
Okay,
Are
sir.
you with me?
Please, yes.
Sir,
Okay.
sir,
Yes, please, Augustine.
please, what about time?
What about what?
Time.
Time.
Is it? Yes, time also changes rapidly. Whereas when we enter afternoon, what about it?
So, can you tell us some component parts of a time?
You know, what I know about time is the differences about
So,
the
what is the
yes.
definition
So
of a system? Can you give us the definition of a system?
okay, sir.
I'm
System.
listening.
Okay, system basically means things that are working together.
No, when you say things that are working together is wrong. There are key things you must mention. And so, what did we say a system is?
Oh, sir.
I'm listening.
So we made mention of interrelationship.
It's not the interrelationship I'm talking about. There's a key word when you are defining a system. I just want that word. Can someone help me, Augustine? A minute, I'm coming. A minute.
They're related.
So hello. So I think says say need the word a group of interrelated components. So when those group of interrelated components they come together, then they work towards a common goal. That's the system. So the dynamic that says explaining, I think you have to get a group of things working together, which can change at any time. So let's take the weather, for example. The weather we have temperature, we have humidity, all those things coming together to form or term as what weather. So the weather can change at any time. So that's a typical example of a dynamic system. Thank you.
Yes. Yeah, hello.
Hello, sir.
I've helped some a little.
So you made mention of a group of interrelated
that is
components
very
working together.
key in the definition.
So
interrelated or component, parts, subsystem. So if you are talking about time, what are the interrelated components that would like time to be a system that it could fall under? You see, don't only be looking at what we say because it is dynamic. So the fact that it's dynamic, you should be able to point out the component part of a time before the feature dynamic features can also come in. Are you getting it?
okay.
For example,
Okay,
if you tell me that clock or alarm clock or something like that can be dynamic because of the time differential, or maybe it is and all those kind of things, even that I can to some extent, because even with time we know that when it is 12 noon, I getting it, it's either continue for 24 hour or 12 noon, then it's proceed the other. So in talking about, you don't look at only one aspect to say that time is. If you want to mention this as it is, consider which component of time are you talking about. So these are some of the things I want to draw your attention. Anytime I want to cite some examples, so far as I saw someone mention economic system. Yes, economic system can be an example of a dynamic system, because economic system has a lot of components, a lot of parts. Taking Ghana, for example, there was a time our economic system was in shambles, a time was stable, a time we have to go to junk, a time you have to go to IMF and all those things. And because of that, it became difficult for even people to predict their investment and all those things. That's why I see that recently, even when the dollar stabilized and they wanted DSTV people to reduce their prices, one of the things they said is that they can't trust that the Ghana economic system, as we are experiencing, will be that stable because of what experience or what previously what has been happening. So economic system can be a dynamic system. Yes, Prince.
Sir, please, what of weather and climate? Can it
Oh,
be?
it's even in the slide too. We have talked about it. It's even in the slide.
Okay. Thank you, sir.
Okay. Then we have stable or static system. So if it is not dynamic, it is what? Stable. So in a stable or static, there's no significant changes taking place. Unlike the dynamic one. Unlike the dynamic one. So a stable or static system, this is a type of system that maintains its state or condition over time with minimum changes or fluctuations. So with this, that's why it's stable, static. It is a type of a system that maintains its state or conditions over time with little variations or changes or fluctuations. So a typical example in, yes, Mariam Ponsa, your hand is up.
So please, can you say that this one, can you use climate as an example of the static approach? Can you use climate as an example of the static approach? I want to know. Thank you.
Climate as an example of a stable or static system.
Yes, a stable or static system.
Okay, I will not even answer. Your colleagues will answer. Yes, let's answer Mary and Ponsa.
Sir, please, for me, I said no.
Why no?
Sir, now looking at the climate, so we said is the climate is the average weather condition of a place. So as and when climate keep on changing, there are things that we were not experiencing before, but now that we are experiencing it. The last time I was speaking to someone on, initially at noon normally comes out when we are in the middle of the month. But as we speak, or from now, you realize that at the end of the month, that is when you see the moon fully formed.
Okay.
Thank you, sir.
I see Samuel. I said Samuel Edu said, please let me hear you. What's your response to to Mary's question?
Climate cannot fall under static or system because climate keep on giving out different results as time goes on. So I think that will fall under the dynamic system.
Yes. Okay. There's Prince. Gonu.
For me, I would say a climate is a static system because the atmospheric weather condition over a place for a very long period of time, and then they have been stating 35 years. So if the weather is changing nowadays, you cannot just stand up and say because it has changed, the weather or the climate has also changed. It takes a long time before a climate can change. So I would say it's a static system, but yeah.
What is climate, Prince?
So the climate is the weather condition of a place over a long period of time.
It's not over a long period, over a period.
Okay, over a period. And then in some books, they have been adding 35 years to it.
You see, you are talking about average weather condition of a place. And we all know that even within a year, there are a lot of changes. Within a year, for example, you see, when we say weather condition, the weather condition, weather itself is a dynamic system. So how can a climate become a stable system? whilst we are talking of the average weather condition of a place. Don't forget, we are saying that with a stable or static system, it maintains its state or its condition over time with little changes, But climates do not have that little change. That's why we are talking about climate change, its variation. If it is static, how can we be talking about climate change and climate variations and some strategies and methods to mitigate these climate issues? If it is a static system, that means that there was no need for even be talking about climate change concept and where we say the climate is changing and all those kind of things. If it is a static, if it has maintained its state, its form, its condition over a period, then why are we now talking about climate variations, climate change, and climate stuff? Friends, so climate is not a static or stable system. Please take note, when we say stable or static, it means that it maintains its state, its condition over a time. And it is subject to little or even no changes. But climate is not subject to little or even no changes. Okay.
Okay, sir, I understand.
Now let's look at some Buddha identified three basic aspects of a system. They say that according to him, every system must have a structure, it must have a function, and it must have what? Development. According to him, when talk of the structure, he's saying that every system should be made up of components and connections between them. And we all know that either a simple system or a complex system, they all have components. Input is one of the component, process another, output, feedback, they are all components of what? Simple. In terms of complex, there could be a multi-components which are interrelated. And they all work. That's why you see the arrows connecting each other. That's the connections, the relationship, the interconnection that exists between them. They work to achieve their common goal. Then functions. Functions has to do with the flow, the exchange of ideas. That's why I say that exchange relations, which forms the connections that exist between them. Then the development, we are saying that it embraces changes in both structure and function, which takes place over time. And what we are saying that these changes can be induced internally or it could occur simultaneously as well. Now, when you are using system approach in your research or in your studies or in your inquiry, there are some steps you must go through whenever you are using system approach. First, you must identify the element or the component part. So, for example, maybe you are conducting a geographic research. Let's say you want to look at how geography teachers are delivering so far as 21st century skills is concerned. So, in using the system approach, the objectives that you have set for yourself, your research question becomes the various components of your research as a system. So in developing a system framework, your objectives becomes the element or the components together with the various theories that is helping you map up. That's why in every we have what we call conceptual framework. Conceptual framework gives you a typical picture of a system of your research that tells you how the various parts are connected to give you the more or less like a roadmap of how the whole problem identified can be resolved. If it is a field work, you may be a Galamsey site, a field where you are going, as you research, you find out the issues, you develop certain hypotheses, educated guess. So in various parts and the various things that must be So that is the first thing in using a system approach you must do. You must first identify the various component part or element. Then you must also appreciate the relationship that exists between these parts that has been identified, and how are they going to work collectively to be able to get the solution that you intend to achieve for the problem identified. Then you must also evaluate the result of the interaction of the component. You must evaluate the result of the interaction of the component. So their interaction, the various parts, how they interact with each other, you must be evaluating to see whether they are interacting in the right way that you wanted to achieve the result or otherwise. Very, very important. Other than that, that's why in every research we have what we call monitoring. It's very important to see that whether the various variables are really on course or there may be some control that you must put in place to be able to the right thing. The assessment of the impact of these various parts that are working together. That's why identification of the impact of the end product of the system or a new input from the outside that probably would have influenced the system. Then you need to also understand the dynamic nature of the system depending on the kind of investigation you are conducting. And because some of them, they are dynamic, the issue of identity, they are quickly changes that may occur, which if you don't monitor it well, it can also affect the kind of findings or result that you are going to achieve. So you must also appreciate if it's a dynamic nature, you must put in the necessary change that will help you identify and monitor to see that the right results are being achieved. So these are the steps that you can follow whenever you are talking about any of them. Now let's look at some examples of systems in geography, which my sister was patiently waiting to hear. Though we have mentioned some of them, we can still talk about some of them here. So we have physical systems in geography, and some of the components of physical system, we can talk of the geomorphic. And when we say geomorphic is from the word geomorphology. And when we talk of geomorphology, it's basically the study of the processes and the origin of what landforms. So within the environment, there are various landforms like the plateau, wave cut platform, rift valley, block mountains, a lot of them, caves and all. These landforms are all geomorphic features. Can talk of soil, climate, hydrological, and biotic systems. These are all examples of what physical systems in geography. You can also talk of human systems and the human geography, which can include components like the social and cultural processes in human organization. And within the human system, we can also have what we call agricultural system, which I mentioned earlier on, industry and service system, settlement system, transport and trade system, societal systems are all examples that falls under human system. Then ecosystem, as we mentioned. So this will focus on the current concerns of sustainable development through the study of integration of human and natural systems within the ecosystem. And there are more examples that can be cited as I use this three broad-based examples. Any question on the system? I think I've shown this diagram already. So any question on that before we move on to the model base? Any question? Any question? So we can continue. Okay, Sammy.
So my question is, so the examples you showed under
I think the line is breaking. I don't know if I'm the only one.
that's the approach system.
Is that the example that we cited in under geography is what? Hello?
Yeah. The human system, the human system, the ecosystem. Are they all under the first system we learned about?
Which first system are you talking? Are you talking about system approach or?
Yeah, the system approach.
Yeah, they are all examples of systems in geography. Oh, I am not getting your question right. If you can type it, because it looks like your line is breaking at a point. If you can type your question, so I'll be glad. Mary, your hand is up.
Okay, so please, I wanted to know that we started with the method of geographic inquiries, and I want to know if the system approach, um, the types of systems, the steps in system approach are all under the geographic inquiries. Thank you.
Yes, system approach is one of the methods of geographic inquiry. And that's one that we have discussed. We are going to another method of geographic inquiry, which is the model based. So all that we have discussed is all under a general system approach. Just that we went into detail so that you'll be able to know the differences. And that's why the steps we are talking about. If you are doing any investigation, these are the steps you have to use in your geographic and even in research wise. I remember my PhD, I used this procedure to be able to develop my framework, conceptual framework. So it's not even in the area of geography, it could be in the area of other research work as well. So all what we have discussed is under system approach. I don't know, Mary, if I've been able to answer the question, or maybe if I didn't get it right. Hello, Mary. Hello.
I think she has understood what you said, so we can proceed.
Okay, so I think it's clear now, so you can go ahead.
Yeah. I wanted to ask similar questions, so let's move on.
Oh, okay. Thank you. So now the next method we want to look at is the model-based approach. Model-based approach. Now, when we say models, a model is basically a simple or partial representation of a reality. Or some would say it is a simplified view of what? Reality. Yeah, water cycle is just like hydrological cycle. It's also an example of open system. It's also a complex system as well. Okay. So a model is a simplified view of reality which presents a partial view of a reality. A typical example is like a globe. A globe is a simplified view of the partial view of the earth that we are residing on. So a globe is a model. That's why I say that it maintains most important features but discard the details for the sake of what? Clarity. So a model can be a theory, a law, a hypothesis, equation or structured idea, a rule, a relation, a synthesis of data or a word, a map, a graph, or some type of hardware arranged for experimental purposes. So there are various, that's why at times you could look at agricultural land use model. So a typical examples of model are the Wundt-Tunnel agricultural land use model. It's a typical example of an agriculture, geographic agriculture model. Talking of the Alfred Weber industrial location model, which others also call it theory. These are all examples of models that are used in the area of geography to give you a picture of a reality. So that gives you the simplified reality, but do not give the details. Okay. So Ferguson will tell you that models are used in the nomenclature approach. That is it. When we say nomenclature approach, they are used in lawmaking because it will also help you when you apply it, and depending on the outcome, will help you to confirm the sanctity of that model or whether it wants to be subjected to some changes to be able to fit into current modern trends or demand. So if you check the agricultural land use, I'm sure when you do regional analysis and development plan, you come across Wundt-Tunnel's agricultural land use model and the assumptions, and you realize that looking at it at the time it was propounded, it is out of date. It's out of tune with the current happenings. So in using such words, it helps you to be able to also come to terms to whether various models, various approaches are in tune with current happenings or otherwise. Now, want to look at some features or characteristics or attributes of a model. One of the features or characteristics of a model is that a models are selective. Selective in the sense that, as we said, it does not present all the features that it's supposed to present. They only provide a partial view of the real world. That's why if you look at the globe that you use in your classroom to teach, which is representing the earth, on the globe, it doesn't show you all the things on the earth. True or false?
True.
It only gives you a representation of the earth. That's why I say it's selective. It just provides a partial view of some of the things that you want to see. And it is only the globe that you are able to identify a longitude and latitude and all those kind of information. We're also saying that a model is structured. Structured also takes you to the idea of the system, meaning that they also have some component or some parts that have some relationship among each of them. So we are saying that a structure and a relationship between each component are clearly identified. So like the example, the Wundt-Tunnel agricultural land use model, you could see that the concentric model, the 5 concentric model, where we talk about the main one, which is the city, followed by the second one, which is the intensive or dairy product, that is of the view that looking at the perishable nature of these products, like milk and those perishable vegetables and those things, it should be produced closer to the city. Then the third one, we can talk of the fuel, forestry, because at the time he was propounding the model, he's of the view that we need fuel, wood, and those things for cooking, for other fire and all those things. So it must be the next important thing that must be produced close to the city. Then the third one, which is the ring, he talks about the grains, the production of grains like maize, rice, and those things that, because it's not perishable, it can be a bit fast so that it can transport itself and all those kind of activity before he came to livestock rearing, where he believes that, in fact, some animals can even transport themselves to the city. You don't need to carry them here and there. So you could see that every model is structured and their various parts are well identified and clarified. An example is like what I've just cited with you. So if you get the material and go to page 8, where we have theories in geography, you could see that the agricultural land use model is there and the various concentric things are there. But we'll also talk about it in the unit 8. Okay. Then the structure of the model can be readily modified as a result of testing against reality, and hence we can say that model is also dynamic. So based on available evidence, so one of the things that was criticized by the Vuntinen model is that he was trying to say that at that time the only means of transportation was Oscat, and we know that these days there's refrigerators that are available, technology that even perishable products are transported from a long distance to villages because of the presence of refrigerators and all those things. So you remember, fine ice and all these things are produced in Tema, and they bring it as far as Elvina and other places for people to buy. So you see that when evidence or suggests that the model is outdated, model gives room for that changes to be done to reflect current situation. That's why we are saying it's dynamic in nature. Another example is that it's predictive in nature. We can use model to predict if this and that are in kaput or in connection, then we can suggest that this may be the next action or this may happen going forward. So we can also use model to make some predictions as well. Some predictions. So these are some of the examples or characteristics of a model. Any question on what I've any question?
Sir, please, you can proceed.
Okay. Then let's look at the usefulness of a model. We are saying that through model, and as already we have indicated that one of its features is selective in nature. So because of that selectiveness, the isolation of the problems and its components. So that's why we are saying that the model through selectivity facilitates the isolation of the problem and its components, which are very critical aspects whenever you are doing any investigation. Whenever you are doing any investigation, one of the most important things is to be able to identify the problem. So if you're able to identify and its related component, that is a very key focus so far as your research is concerned. That's why any supervisor who is supervising a research work, he wants to see how clearly your problems are identified and how the problem give rise to your objectives. So you go for presentation, they're asking you, which of these objectives is featured in your problem statement? Because I've read your problem and I'm not seeing how this problem is giving rise to these objectives. So one of the selective nature of model gives you the ability to isolate the problem and its related part, and that will give you the edge, because see, all the investigation you are doing is driven by these parts which become the objectives or the hypothesis. So model helps to facilitate that, be able to single out the problem and its related part and how it can be dealt with in that direction. We are saying the structured nature of the model provides a theoretical framework within which hypotheses may be formulated and tested as part of what? Sound scientific inquiry, which we have even mentioned some of them. Like the agricultural land use model, as you use that, as you test it against current reality and the evidence suggests otherwise, then there's a need for some revision to be done. If it confirms same, then the model can graduate to the point of theory over a period. Now, conformity to the model will help the development of geographical theory, whilst deviation from it expected may form the basis for later investigation. So if the model confirmed with current realities and the happenings of the day, then we can also say that it can help geographic development. But if it is otherwise, then there must be a revision and some form of further investigation must be conducted to see what best can fit current realities and otherwise. The greatest value of the model is that it may reveal order in the pathing, enabling generalization to be made, theories to be formulated, and eventually valid prediction to be done. So, you see, anytime you are dealing with, we talk about concept, we move from concept to facts. And when facts to generalizations to theory, then it graduates to law. And at every point in time, there's some form of subjection of these models, fact, concept, theories to current realities. When evidence validates, then it graduates from a model to theory. As it continues, which becomes a wide world acceptance, and then it can graduate to law. So model also plays a role in helping us to determine whether a certain situation could generate to generalization theory or predict the ability of becoming a law. So when someone says that waterlogged areas are liable to flooding, it's a statement of facts, and this could be a generalization if the whole worldwide, wherever you go, a waterlogged area is prone to flooding. If you are talking about Ghana, yes, Ghana, we can authoritatively say that waterlogged areas are liable to flooding. This could be subjected to the context of Ghana. If you go to other areas and waterlogged areas are not liable, then you cannot, these findings cannot generate to law theory or a generalization, because a generalization has a wider applicability and acceptance. So that is how model help in some of these rendition. Okay, any question on the model before we move on to the third one, the quantitative approach? Any question?
So let's proceed.
Then we have quantitative approach. The quantitative approach, we all know, emerged during the quantitative revolution in the 50s. And it had the effect of broadening and intensifying the use of models in geography, and also shift the emphasis of geography from mere description to explanation, where you have to use numerals, statistics, figures, graphs, flow line maps to provide explanation to geographical occurrence and phenomena. So statistical method, that brings in the issue of statistical methods, have been the concern of geographers for many years. And these days, most geographers are all using these statistical tools to quantitative figures to give you an idea of what is happening. So a typical example is like those who are into weather forecast, the meteorologists, when they come and give you figures, temperature of this degrees Celsius and that, they give you the flow line, temperature circulations with figures and all those things. These are all quantitative dimensions research they have done and be able to inform the public of various happenings within the globe. For example, recently saw that there were some information about the rainfall pattern within some few months, and they were giving you statistics in terms of the percentage so far as the humidity level and all those kind of things to give you an impression that there will be more water within this month and this month. These are all some quantitative analysis that they've been able to do to project that analysis for you. So we use frequency, statistical diagrams, graphs, flow line maps, and all these things in the area. So geographical techniques deals with numerical data. And in spatial analysis, you are likely to find methods like cluster analysis and discriminate analysis in geographic studies, which all this is just to let you know, not to bore you with these analysis, because these are statistical analytical tools that at the master's level, if you want to do your MPhil in geography, whatever, you'll be exposed to some of these analysis. So I don't want to bore you now. I just want you to know some of these things. Okay.
Yes, sir.
Now, why the use of statistics in geography? We are saying that statistics enables geographers to be more informed or objective in their decision. Don't forget that quantitative philosophers or approach believes in the objectivity. What they believe is that whatever is happening in the investigation that you are doing should be independent of the researcher. That's why for them, they go with the quantitative, and the quantitative people will be more of using questionnaire. So the questionnaire, if I want to assess, let's say, your emotional intelligence level, I'll just have a skill that is used to measure your emotional intelligence. And you will just take, and in taking those items, in summation, I'll be able to tell whether your emotional intelligence level is high, moderate, or low. I will not take your emotions, the time you were feeling, whether you were crying, whether you were laughing, I will not take it into consideration. That's the quantitative objectivity. Unlike the qualitative people who are subjective in nature, that who want to take your emotions into consideration, into even posing the question, and your mood and your physique and the manner in which you responded speaks volumes to the qualitative researcher than the quantitative. So you are saying that it enables geographers to be more objective in their decisions. For statistical testing is based strongly on mathematical theory and is test the validity or the
Sir, please, your line is breaking. I can't hear anything. No, please, is it just me?
It's not only you, it's everywhere. Shamsuddin, are you there?
Yeah, I'm here. Say, I'm here.
Yes, I didn't hear from you.
Please come again.
I said, yes, I didn't hear from you during the lectures.
We'll talk after the lesson, please.
I think sir is gone.
Let's take a look. Maybe we'll come back.
Fine.
But this course is somehow. Am I the?
Charlie, it's not
Am I
easy.
the only one?
Hey, it's not easy, Charlie.
I don't know if I'm the only one. See,
For those of us who came late, it's even worse here.
Why you thought you were coming to learn A B C D?
You. Yes,
I mean,
find them.
why?
It's more than pure research, Charlie. Yes, sir.
We thought we are coming to talk about weather and go away.
That is brother. Look at this place.
Ah, Charlie,
I'm even.
very, very broad.
At the point in the class, at the point, I said no. I left the class. I went to stand and I came back. I said no.
Hey. Mary, are you there?
Yes, I'm
Course
around.
rep, can you please contact the teacher for us?
Please, can you
Course
contact
rep.
me? Course rep, please contact for us, okay? Steve, please drop him so
Okay,
that we know.
let me call him.
Okay.
Oh, okay.
But please, for this course, there's someone should volunteer and then meet us and then teach us. So it's not easy. We beg.
Yeah, Alex. Yeah. Bye.
When I said James story.
I went out to him.
Yeah, you should have you. Oh, medical to be done.
Actually, easy. I don't know.
Hello.
We rubber.
Hello.
Yes, Steve.
Oh, sorry.
We are listening.
Then I was asking a question. No one was responding. Only for me to check and I realized that, oh,
I said you are
like I was asking a question. No one was responding. So let me check my people. Only for me to realize that I'm gone.
Sorry. We also waiting for you.
So where did I get to so that
Okay, please, we were talking about the qualitative and then quantitative approach. How qualitative approach will use emotions in terms of when you were describing or explaining your point.
oh, okay. Okay. So this one, well, I said that statistical methods provides this quantitative also provides geographical data to enable geographers to be able to test the validity or the application of these model to real situations. Don't forget that in quantitative approach, we formulate hypotheses. Unlike the qualitative that we do not formulate hypotheses. And hypotheses are subject to testing. But when you test, either you fail to reject the null or you reject the null hypothesis. So this quantitative approach with the use of statistical methods enable geographers to test the validity of various hypotheses, models, or applications to real-world situation. Another usefulness is that this quantitative holds a very essential point when it comes to geographical models, theories, and concepts, so far as the physical and human interactions or environment issues are concerned. So once we do these analysis, we are able to get human views and quantify them to get a better picture of the issues and how we can analyze these issues to get the best of the result. But in as much as we are saying that quantitative is more objective in nature, we're also saying that even the data itself, that kind of data to collect, is done by a human being. Which data and how it's collected, the analysis are even done by a human being. So there's some level of subjectivity in there. But the emphasis here is that the extent of it, when it comes to quantitative approach, is less than that of what qualitative approach. Because in a qualitative approach, even your mood, your physique, it speaks volumes to the researcher who is a qualitative inclined, as compared to the quantitative researcher. That's one. Well, if you were crying taking the questionnaire, he doesn't care. If we're laughing taking the questionnaire, he doesn't care. All what he matters, you have picked it. He does the analysis and push it forward to provide his findings. Now let's look at aspects of quantitative approach. There are two main approaches when it comes to quantitative analysis. We have what we call the descriptive statistics.
Hello, sir.
Yes, please.
The slides are not showing.
The slide is not showing.
It's on. Yes, it's on now.
Are you sure?
It is on now.
It's showing,
Maybe it's from
sir.
his side.
It's showing.
Okay. Because I'm also seeing now, I'll switch to where I can see you so that it doesn't go off again for me to speak in vain. So we have descriptive statistics or descriptive approach, and we have the influential statistics. And this one, in every research, no matter the pure sciences or social science education, these statistics are mostly used. So the descriptive statistics focuses on description of a set of data in a distribution or of a group or population network. And normally when the distribution are normally distributed, that is where descriptive statistics. So we do this in order to be able to make some form of what? Deductions or inference. And under descriptive statistics, we have what we call the graphical method and numerical method. The graphical method is the ones that we are able to present some information or some findings or results in a pictorial form. So, example, when people present their data or information results in a frequency histogram, in a bar graph, pie chart, dot map, flow line maps, are one of the way we present descriptive data. That's what we mean by the graphical representation. Then we have the numerical representation, which the numerical representation deals with the numbers in its analysis of data. And here we can talk of the measures of central tendencies, like the arithmetic mean that we use to calculate in our various statistical ways. So there are some research, you will see frequencies and percentages. These are all numerical forms. Some will use mean and standard deviation. Some also use the median, the mode. And these are all descriptive statistical data that analysis that is being done. So for example, talking about the median, we all know that it's a set of values which is arranged from the smallest to the largest, and the median value of the middle item is determined. The same thing when you talk of the mode, it is the value which occurs with the greatest frequency in a set of what data. And I know you know all these things, so these are just to give you an idea of how some of the descriptive data are used. I've talked about the range, the measures of central speed and variability. These are all descriptive statistical analysis that are used in descriptive analysis. Then we have standard deviation, which looks at how distant the individual values so far as the distribution, the extent of agreement of their responses. That's why we normally use it in conjunction with the mean. So if the mean is 3 point something, if it represents this, that their responses homogeneous or there's dispersion, do they agree? This is why we use the standard deviation to also help appreciate some of these things. The mean deviation, quartile deviation are all examples. I just to let you know some of the descriptive statistics that we do. You are not going to do any statistical analysis so far as this course is concerned, so don't be bothered. It is just to show you to you. Then we have the next one is the influential statistics. Influential statistics. And this is the type of statistical method that combines two or more data sets to answer geographical issues or questions and determine some relationships. So under the influential statistics, we have what we call correlation, which normally investigates the interrelationship between two or more variables. So for example, if families with many children tend to have higher income than families with fewer children, we say that there is a positive relationship between the two variables of family size and family income. So this is correlation, and there's a SPSS is available to help you do some of these calculations as well. We have regression analysis, which is if you want to look at the relationship that is between two variables and the researcher wants to establish the relationship of these two variables for forecasting and to know the contribution of each other. You can use regression analysis to determine that. And we have chi-square, and like I said, this is to just expose you to some of the influential statistics that can be used in quantitative. You are not going to do any influential analysis in this course, just to expose you to it. We have the independent sample, what we call t-test, which is designated to determine or analyze if two variables relationship remain the same or varies under different categories or conditions of the control and the tested. So for example, if you want to look at male and female, which of them normally perform well when it comes to geography? And because male could be one sample and female, so that could be t-test, independent samples, as against their performance in geography. So these are some of the quantitative approaches that can be used so far as descriptive and influential is concerned. Any question on that before we move on to the last one?
Sir.
Yes, please.
Sir, please, can one say,
please go ahead.
Sir, can one say the graphical method can it be defined as just the pictorial representation of data?
Yeah, that's what I said. That's what I said. And it is in the slide.
Okay, thank you.
Any other? Okay, then now we look at the scientific approach, which is another approach that is used in geographic inquiry. And as we all know, when we talk of scientific, it's a procedure or a system that is used to approach problems by adapting some steps, some sequential steps or logical steps to arrive at a certain solution to the problem. That's why I say it's a way of approaching problems and involves a logical sequence of steps leading to certain conclusions based upon precise and stated what evidence. If the conclusions are satisfactory, then an explanation at a given level of truth is offered. Now the question, what are these logical sequence or steps? The first step is for you to, in scientific approach, is to identify the problem. An identification of the problem can stem from the issues, the happenings within the landscape. So when someone sees that there's an area that there's refuse dump have been dumping there a lot without collection, can be a point of investigation. When something triggers your mind that you do not get why people are doing what they are doing, which in your mind it shouldn't be so, can trigger questions, can trigger. That's why I say this will arise from our study of the landscape around us, and models may be well help isolate the problems within it. So in terms of identification of the problem, it can come from so many sources, from your personal experience, from what is happening around the landscape, from what you'll be reporting, what you have also read, are all many sources of identifying a problem. Now, having identified the problem, the next important is to generate some form of what educated guess or hypothesis. And these hypotheses is to help resolve the problem as identified. So hypotheses are basically an educated guess to help you to determine whether this is the cause of the problem or the otherwise. So it is basically the term that is used to describe the starting point for investigation and possible solution to the problem. So when you develop it that way, then you are in a position to also go to the point of your data collection by developing your instrument that you need, the various data collection tools that you want to use. And this can involve both secondary and primary data source. So the secondary data can be published data such as maps and census returns, and it can also be a field work where you go for primary data sources to collect your data. Now, when you collect the data, the next thing you have to analyze and test the data you have acquired to be able to determine whether the hypothesis you generated is something to go by or to reject it. That's why the fourth one talk about testing the hypothesis. So where you could use your quantitative techniques such as the ones we have talked about, be it the influential or descriptive, to determine analyze the result, and based on the result that will come, will let you know whether you have to reject the hypothesis, the null hypothesis, or you fail to reject. And that leads us to the fifth one, which is the evaluation of evidence, leading to the acceptance or rejection of the hypothesis at a given level of significance. Now, if you fail to reject or you reject the hypothesis, then what is the conclusion? What is the inference? So there's an implication. So that is, it may be possible to confirm or either to unproven assumption and hence add to the body of a theory. Alternatively, what can also be done is that a weakness in an original hypothesis may be uncovered so that if it becomes necessary to return back and correct it and get to the field again. That's why at times it's very important that you get the right hypothesis, the right research objectives in order not to go and backfire. Because if you don't get the right data to respond to, so for example, if your objective was to look out for the methods teachers use in teaching geography, whether it's a 20, then at the end of the day, your findings could not point out to a specific method they use, then you have to go back to the field and collect the appropriate data. And that is why it is important when you are determining your hypothesis and doses, you pay attention to these key issues. But they are very, very critical in helping in that direction. So these are some, as I said, of, yes, scientific approach is cyclical. It's a continuous process in nature because your findings, your results may have some limitations. That's why we have limitations of the study. And we also have what we call suggestions for further study. Areas probably you could not tackle, that could have been a weakness. You make suggestions that people can take it from this angle as well. So it's cyclical, which at times can make you go back to the process again. So it's cyclical in nature as well. So these are some of the approaches that are used in methods of geographic inquiry. Any question up to this point?
I believe we can proceed.
Okay. Share the other units so that we go through. So can we say the scientific method is modern? Scientific method, yeah, it's one of the approaches that is modern as well, that can be used by researchers. Okay. Now the next thing we want to look at is the unit 5, sources of geographic knowledge. So we are looking at sources of geographic knowledge. We are saying that geographic knowledge is any information connected to a location that includes data about physical and human characteristics or phenomenon at any place on the planet. So any information you gather which borders on the physical and human activities so far as the planet is concerned, and we are talking about the planet Earth is concerned, borders on what? Geography. And as geographers, to be able to respond to issues and provide explanations, there's a need for you to have some source of what? Information or data. So you can only respond to questions, provide explanation descriptions when you gather data from diverse sources to be able to respond appropriately. So geographical knowledge can be sought from two main sources, either the primary source or the secondary source. The primary source are the source directly from the field that you have been there yourself. But the secondary can be from data from unpublished and published information as well. Now, when we say primary data source, what are we talking about? A primary source is an account of an event by a participant or eyewitness at the time of the field. So if you look at the picture there, you could see that there are some gentlemen and a lady on the field looking at their maps. Have you seen it?
Yes, sir.
It's a typical example of the primary data that they are trying to. That's why we are talking about an account of an event by a participant or eyewitness. The so baby na 57 and media for we interview an eyewitness. Oh, no, a boy say this is a primary source. So a primary source of geographic data is basically field work, not armchair work. Field work means you have to go to the field, not sitting in your room and manipulating figures. So we can talk of, apart from field work, work of arts, scientific or sociological data, archaeological artifacts. So when you go to the field and see those artifacts and you try to pick information from them, we have official government proceedings also constitute primary sources. So government proceedings where you are there listening, getting the information from the sources of government, they are all primary sources. Now, types of primary data sources. We have what we call the oral literature, which is an eyewitness account. We have autobiography, that is a personal history of someone told or written by the person himself or herself. Then a proceedings of a meeting is another example of primary data source. So we want to go to a meeting and the secretary take meetings, proceedings, and those things. The next time he has to be able to help you go through the previous minute, and they are primary source. Personal experience of the geographer. Your personal experience. I remember my PhD work. The problem stemmed from my experience over the years. That became the focal point for my PhD work. Then personal experience of the geographer, as I've said, and also from an authority or expert in the subject of research can also be a primary source. It's when you go and interview an expert, for example, you are looking at the reclamation of the environment degraded, and you go to the EPA boss, environmental protection boss, like Professor Amal Kluche Brown, and you interview her from an expert or authority of the subject area. That's a typical example of a primary data source. Then from diaries, letters, and memos that are shown in correspondence, they are all examples of primary data sources. Then interviews, speeches, oral histories, personal narratives. Boss story, oral history of the antecedent of the 1988 riots. They are all primary. Then scientific data and reports, when you pick it yourself from the field and all those things, they are all examples of primary data sources. Now, from there we come to approaches to field work. Primary data sources, as we said, is basically field work. And in field work, there are two main approaches to field work. We have what we call the field teaching and field research or investigation. When it comes to field teaching, this is where the teacher directs students as to what to look out for during the field survey. So though it is inductive in nature, it does not often focus on problem-related issues because here is the teacher directing the student what to look out for and all those things. Unlike the field research or field investigation, where the students are allowed to discover, use their own methods of investigation or inquiry to identify, collect data, and be able to analyze and report their findings. That's why I said this adopts a scientific mode of inquiry and uses qualitative and quantitative data collection methods such as observation, interview, survey, pre-test, post-test, measurement. So field research approach usually adopts a problem-solving approach to research. Field teaching can be like excursion. Field teaching, yako excursion. Maybe I did the excursion, then you try to show them, let them teach them, so that when it comes to a class, it become very easy for them. That's field teaching. The teacher is more dominant in field teaching as compared to field research, where the student or the learner becomes dominant. Now, what are some of the sources of secondary data, as we have mentioned that of the primary data? They are normally printed secondary data sources whose content have not been subject to rigorous peer reviews, as in the case of published data sources. So we are looking at unpublished sources of secondary data. When we say unpublished, because it has not been subjected to rigorous peer review, unlike published data sources. So there are some publications online, most of the publications online, some of them, they are not subjected to peer review. So that's what we call unpublished. So there are people who call, some journals, we call them predatory journals. They just take the money and publish it for you without doing good peer review assessment. So example of unpublished sources include files, logbooks, and various registration forms of many government and non-governmental departments. Others can include original essays and dissertation written by geography students in schools, colleges, and university libraries. So the project work people did at the college level is a typical example from published source of secondary data. It's way of project or will bind the control library or people you see and you publish. It's still on published sources of secondary data. So published sources of secondary data, these are data sources which have been published by reputable and non-reputable publishing organizations mandated by law to publish. So in Ghana, we have the Ghana Publishing Company, who are government publishing accredited. So that's why they publish the gazetting and all those documents that is. So examples of these are both online and hard copies books that has been published by Sage and all those publishing companies. Encyclopedia is another example. Journals, different types of bulletins, magazines, fact sheets, research reports that has been published, theses, conference proceedings, among others. Newspapers are all examples of that. So another example can talk of statistical abstract bulletin report issued by government department, especially the statistical unit. And we know that in Ghana, Ghana Statistical Service are in charge of these reportings. So the census report is a typical example of published sources. So the bulky of most of these publications is generally made up of tables derived from data collected. So example, statistics on household living standard in Ghana by the Ghana Statistical Service is a typical example of statistical reports. Some of them is quarterly, monthly. Bank of Ghana quarterly bulletin are all examples of published sources of secondary data. Statistical information concerning international passengers movements found in shipping and airline are all examples of this category. We also have what we call the miscellaneous report of government and non-governmental organizations. And these include reports that these are not reports specially made of tables. The tables that feature in such reports are normally incidental and used mainly to summarize the activities of the agencies over the period covered in the report. So miscellaneous report from government and government agencies. So examples of some of these miscellaneous reports include the 7-year development plan that we have by the planning commissions. So various development plan, various climate strategy plans that we put in place are all within these, be it non-governmental and governmental organizations. Then we have published maps, which provide information on both physical and human landscape patterns. And we have a number of them: Maximilian World Atlas, Phillips New World Atlas, among others that we have. So the maps we have, these are all examples of published maps that we can also use them in our analysis. Just that you must make sure that they are very current. Then we have standard textbooks. These are those contain statistical data to a limited extent, dealing with topics that range from monthly temperature. So both geography books data that we have, they are all published sources. And also for global patterns, the production yearbook, which is mostly published by the Food and Agriculture Organization, the United Nations Organization, the UN, which has various issues on, let's say, crops, livestock, and other forms of agricultural produce are all forms of public secondary data. So then research reports and learned journals. There are great variety of such materials in geography. So the research papers of our universities, the Bulletin of Ghana Geographical Associations, which is a organization that they annually, so we have Ghana Geographic Association, we have Ghana Geographic Teachers Association, which they meet annually to present conference papers and publications in the subject area geography. These are all area of published sources of information that are shared with the world. We also have magazines and daily newspapers, which are also shared across the world. So we have the New York Times, the West African Magazine, Newsweek, Daily Graphic, the Ghanaian Times are all magazines and daily newspapers which go through editorial sections. But unfortunately in Ghana, most of these newspapers are owned by political appointees or political people, lineage. So most of the editorials are skewed to give certain impression and certain feedback. Then we have literature, which include novels, short stories, and travel books that are sources of objective data in acceptable sense of term. Then we have electronic media, which we all, these days we are using, the television, radio, Zoom, Google Meet, internet, which are all some, we publish some information over there. With some of them, when you publish information that is not good, the administrators of the device, the media can call you to order. Social network, peers, colleagues, other researchers, or superior teachers, they are all examples of sources of geographic data. So that is that with that of the sources of geographic knowledge. Any question? Any question or contribution?
So please, I believe there are some comments at the in-call messages. So if you could check, please.
Oh, okay. Let me check. Okay, someone is finding an example of secondary sources. I'm sure we have had, okay, let me see. I've addressed that one. Can we say that the scientific method is the modern and verifiable? I think I've addressed that one. Yeah. Can we say that field teaching is guided? Yes, it's guided. An unpublished article or thesis is an example of secondary data source. Yes, if you have written your article and there are people who have written their own project work and they have uploaded to academia.com, it's still unpublished secondary source, or you go and put it at the library or your library and someone comes to pick it. It's a secondary source because the person who is picking it did not go to the field. to get that information. So it's a secondary source, just that it's not published because it has not been subjected to some peer review to accept it to be a document that can be put. Your supervisor is not an accredited publishing company, editorial person or whatever. So unpublished articles or thesis is an example of secondary data source, but it's unpublished secondary source of data. What about if I write books and go out to sell them? Yes, that's what I call standard textbooks. When you write books, it must go through some peer review. That's why before you have to get the SIB. Is it SIB number? Those publishers, you have to get SIB number. And you
Yes,
send
please.
copies of your books, they'll go through those processes before. If it's just a mere handout there, like the handout time, that one there is not published secondary source because it has not gone through any IRB international and all those kind of things. But if it has gone through that process, then it's a published secondary source. But if you just wrote it and you are selling, like some of the handouts we are selling to, then that one you cannot say it's a published secondary source. Then also, is it published by a recognized publishing company? No, what it may be recognized or it may not be recognized, but it has gone through the procedure and there's a validation, there's a proof that this has been gone through the peer review rigors. Why not? Because it's not possible to know all the publishing companies. So that's my feedback to Ima. Then I see Augustine. Is it my network or is it a general issue? Well, what's happening, Augustine? Yes, that's ISBN number. That's what I was talking to. Okay. So I guess I've addressed all the issues in there. Any other question or contribution? Any other question or contribution? Oh, is it true that the line is breaking?
Maybe from his side, say, we should proceed.
Okay. Okay. So I guess we'll wrap it up here so that I can go and alert my family at church so that
Sir.
Yes, please.
Sir, please, before starting the lesson, you were saying something about the.
If you can type it because your line is not clear.
The question or the quiz, so I don't know whether maybe you forgot something like that.
I can't hear you well, Stephen. If you can reiterate what you said.
Yeah, so what I was saying is that before starting the lesson, you were saying something about the quiz that you have started typing or something like that.
No, I didn't say anything about quiz. I don't remember saying anything about quiz.
Oh, okay.
I didn't say anything about it. If there's a need for me to talk about it, when we get there, we'll cross.
Say something about it.
Let's focus on what we are learning first. Then after, we'll talk about that. Yeah, I have some review questions in the material. You can address yourself with it. So,
thank you,
there are a lot of
really
review questions, objective questions that you can solve them, which will be helpful to you. So there's no cause for alarm. Okay, so basically we are left with some 2-3 units to finish the course. One on the brief on the geographic thoughts, then the one on skills in geography, then we wrap it up with the methods, theories in geography. Theories in geography. So it's almost 10 o'clock. Yeah. Any question on what we have done today? We have looked at 2 units. And so the geographic thought is quite it's quite lengthy. So I'm sure if we want to start now, yeah, it's about 36 slides. And I wouldn't want to bore you too much. So the ones we have done now, you go and reflect on it. When we meet next week, look at the geographic thought and that of the skills in geography. Yes, please.
Sir, please, since this one is lengthy, I believe maybe we can start somewhere. Yes, because this one, looking at the chapter 6, it is too lengthy. And looking at the names, in fact, it is not easy.
Yeah, that's why you need to start on that one. So you have to start early in the morning with your fresh mind. Not the mind that we have bombarded you with the method of geographic thought and sources of knowledge. Then you are now going to combine some of the names that some of you have not even heard it before. Are you getting it?
Yes, sir.
Okay. So we'll continue. But I don't have a problem. Maybe if in the course of the week too, you want us to meet, fine. I don't have a problem.
I'm sure sir will pray for us at church, so don't worry.
So, sir, please, in the course of the week, I will discuss with the group. Then, if anything, I will give you a call.
Yes. If not to, I think next week we'll kill them. Right. Okay. Yeah, so I think that so far I've seen Isaac Pra, I've seen Judith. So I acknowledge that. Yeah, Judith Esanam Daliku. Okay, and Isaac Pra. So I acknowledge them. Okay. Thank you. So on that note, we'll end it here. Then I'll be expecting from you, Stephen. If not, we'll make it next week.
Okay,
Sunday.
sir. Sir, I'll give you a call.
Yes. And then next week, Sunday, that one there, we'll make sure we'll finish them. So that one, we'll make sure we'll finish the unit left. And we'll be done with.
Okay, sir.
Okay. Thank you and have a good day. You can go to church. Bye.
Yeah.
Okay, bye for now.
Okay, sir. Thank you
Bye.
very
Bye.
Cool. Please. I
And the
wanted
way
us to
that
have
the
some
people
few
who
discussions, please.
Make we talk because
Hello.
you class
Please.
people.
Yeah, hello.
We are listening to you. Please.
Hello.
Yeah, please. Looking at the chapter 6, the chapter 6 is too lengthy. So I don't know if we can find time for him within the week. Because of the names that we the names are not easy at all. And this side too, I learned it's been coming. Because there were some questions on these names.
Can you share the questions for us to see?
So I think there was a question on the platform like that on nature,
The
but
Telegram
I'll look for
page.
it and
Is it the Telegram?
I will look for the question and put it on the page. I will look for it and put it on the
Yes.
page.
Yeah. Look for the
Hello,
question and
Mr.
post it.
Steven.
Yes, sir.
Hello, Mr. Steven. Hello.
Please, I'm listening so you can speak.
Yeah, sir. Concerning our course registration, some of us are still struggling to register. They said yesterday they opened the edition, and then those of us who are yet to register will do that. But up till now, we are not getting any information concerning that.
Yesterday, I called the course monitor, that's the program monitor. He assured me they are going to open the portal yesterday, but then I checked, it's still the same. So please, let's go check today. If anything, I'll give the feedback on the page, but I'll still contact them, please.
Okay.
Okay, so Steve, I'm suggesting that we schedule a day within the week so that we can meet the lecturer and then we go through the chapter 6. What do you think? So I think we are also supposed to judge our ideas so that we can come with a day so that we can meet him.
That is what I'm saying.
Yes, that's what the lecturer says. We should organize and call him so that we can see.
Can we schedule it on Tuesday? If it is perfect for all of us, Tuesday, will it be okay for all of us?
And Tuesday
in the evening, no?
Yes, on the 10th.
In the evening?
Yes, I guess.
Please, time.
Time. So, Steve, which time do you think that it will be okay for all of us? Steve, are you
I
around?
believe maybe from 7 will be okay. Yes, I believe 7 will be okay.
Okay. So I think we have all agreed to meet at 7.
Yeah, Tuesday evening, 7.
On Tuesday.
No, we haven't agreed.
Okay, so please, let's make a suggestion. So
Let's make it 6.
Let's make it.
Somebody suggesting.
Maybe since a fan of football, maybe he will not be able to make it. If he is a fan of football,
who is a fan of football?
What matches do we have?
So let's make it Monday.
Tomorrow.
Monday. Don't forget that tomorrow some people are also having lectures in the evening.
No, but this one is nature. So those of us doing this, these are those of us having geography as minor as the major. So we don't have any lecture tomorrow.
Okay.
Please, let's have it on Tuesday. Please, Tuesday.
I think the best thing is we should know. Right now we don't know the schedule for the week, so we have to hear his view first. Then whatever day is convenient for him, then Stephen can communicate with the class so that the class will be aware that this is the time that the lecturer will be free. Then we can also make our schedules to suit his own, not he making his schedule to suit ours. That's what I think.
Yeah, I agree with you.
Okay, so
that means still have to.
So can we do it? So can we do it or know that maybe it is the time will be 7 o'clock any day, as from Monday to maybe Friday.
Yes.
Is the time okay?
Yes.
6 is okay. I think 7 is a bit late.
Stephen, what about the book that he wrote about the last time?
So let's finish with the time.
Okay.
So how many hours?
I suggest 6 to 8. 6 to 8, 2 hours.
Please, any other?
Yeah, 6 to 8.
I second. 6 to 8. Okay. 6 to 8 is okay.
Yeah, 6 to 8.
Yes.
Any day.
6 to 8. Okay.
Yeah.
Okay, then.
But please, everything just left, so we have to continue the discussion in the main group.
Okay. So Steve, you talk to the facilitator so that we know when we meet. Okay.
All right. Please, someone was asking. Yes, sir.
My issue has to do with we have geography and economics. But
Okay.
usually, what we always have is the geography. What of the economics?
I think you should contact the
The
first
economics
minister.
we are doing the economics we are doing only one course this sem. Yes, this block
This semester, yes.
we are having only
That's
one course.
geography only.
Is that the element? No, please.
Element of
Those doing the geography
microeconomics.
major, we are doing only element of economics. That's the course we are doing for only this block.
Yeah. Element of
So
microeconomics.
when are we going to have lectures for elements of economics?
Yeah, the lecturer said yesterday that he traveled yesterday, so he couldn't make it. So I will call him and communicate that, please.
Are you going to have lectures this afternoon?
Yes, please. This afternoon we have.
From where? From when to when?
11:30. We are going to have physical geography. 11:30.
Okay. Up to 2 or 1.
Steven, the other time, Sir was talking about some book. Yeah, do you
Yes.
remember?
Yes.
Yeah, but me, so those two that we are interested, you must arrange for us so that we can get some for us.
Yes. The book saying that each center should have a course rep. Each center. But here lies the case, the centers, we have few individuals over there because he wanted to know the number before printing the books. Please, I wait with me.
I'm also in Sunyani.
Yes. Yes. So that's what I'm saying. Most of us, we are scattered. So each center should have a course rep. However, he should know the number of people in Sunyani before printing the books and sending the books because sending the books will incur a cost. Do you understand?
Mr. Seven.
Yes, sir.
The issue is we don't go for face-to-face letters. We don't go for face-to-face letters. So how
Seven,
that's the issue.
is the lecturer in UCC?
Yes.
Is the lecturer in UCC?
He is in Cape Coast.
Yes.
Okay,
Yes,
I'm in
UCC
UCC
Cape Coast.
myself. I'm also in UCC. So if we can all come together with our centers or the major towns near us, I can contact the teacher, collect the books and send them to your various locations by car.
Okay, that's a good idea.
Okay, that wouldn't be yes. So I'll I'll call you, okay, so that we will discuss that because
okay.
So are we going to
spoke to the lecturer some time ago and he assured me that we should
I didn't hear the question.
have group rep.
Are we going to pay the money to Mr. Seven?
The lecturer in question is that then we give the money to Sloda, please.
No, how are you going to get the books? Are we going to pay to Mr. Seven or who?
If the books,
Sloda.
the books, if you are in Sunyani, I will go to STC.
Mm-hmm.
So the STC car that goes through Sunyani to maybe the north, when you give the book to the car, when you get to Sunyani, they will leave it there for you. So if I don't have a car here in Cape Coast coming to your location, that one it will be difficult for me to send it.
I'm talking about how we are going to pay the money.
Pay to who? For the money, I think Stephen can.
We will pay the money to Sloya. Sloda, we pay the money to you. Yes,
No, pay to Stephen.
Oh, pay that.
Pay to Stephen.
Listen. If you pay to Stephen, he's going to do another transaction, which will cost a lot.
Yes.
And also, if
So
those who are beyond, for example, don't stay in the Volta region.
So, Madam Sloda.
I'm listening.
Please, I hope I've gotten it right.
Yes, my name is Sloda.
Can we pay to you? How much is the book? How much is the book?
I don't know.
One is 5 CDs.
This one?
Please.
One is 40 CDs.
Please wait. Please wait. Hello, hello,
Yes.
hello.
Yes, master.
Hi.
When I
We are
called
listening. We are listening.
Mr. When I called Abode, that is a week ago. Mr. Abode said the book is 45 CDs. That's what he told me. But I
Which
think
one are you talking
yesterday
about?
too, there was another the thematic geography and physical geography. But with nature of
I think I have to
geography,
contact the
I
lecturer so
don't
that
know. For
we
me,
will
I
know
have a
how
book
to
here,
get it.
nature of geography.
So contact him and get back to us.
So slow down.
Yes.
Yeah. So with the nature of geography, I think it hasn't been spoken about. That's the book. So
Please, your line is
I
breaking.
have to
Can't
look for
hear
the
you.
author, that the lecturer, so that I'll communicate
He's saying that
to you.
with the nature
If
of
that,
geography
then if
concerning
you could get it for them, please.
courses, maybe
Yeah.
as for this was nature of geography.
With the nature, the book for the nature of job. Please, those requesting for the books.
What are we supposed to do? Mr. Steven.
Hello, can you hear me?
Yeah, I can hear you.
Someone was asking a question, but I didn't hear what the person was
I
asking
was
about.
asking about
You
who
let's
didn't pay the money.
I will speak with Loda. So any update will be WhatsApp.
Okay. Okay, Stephen, please tell me.
Mr. Steven, your
Yes,
line is breaking, so you can't hear you.
Loda, I can
Come again.
hear you.
Well, Mr. Steven. Mr. Steven. Please, are you there?